Dear students, welcome to my third class on Module 5, Joint Distribution. So, in this lecture video, we'll be discussing few more problems on the joint probability distributions. So, example number 5, the joint distribution of two discrete random variables x and y is given by f of x comma y is equal to k of 2x plus y. So, where x and y are integers such that 0 less than or equal to x less than or equal to 2 and 0 less than or equal to y less than or equal to 3. Find the value of the constant k, find the marginal distribution of x and y, show that the random variables x and y are dependent. So x is given by, so in this problem, this x is given by 0, 1, 2 and y is given by 0, 1, 2, 3. So then the given function f of x comma y is actually what? K of 2x plus y. So now I am going to frame the joint distribution table for the given function with the given set of values. So the table is like this. So taking all x in the column wise 0, 1, 2 and taking all y in the row wise, that is 0, 1, 2, 3. So now at x is equal to 0, y is equal to 0, the value of the function j11 will be equal to 0, and at x is equal to 0, y is equal to 1, this is k. At x is equal to 0, y is equal to 2, it is 2k. At x is equal to 0, y is equal to 3, it is 3k. Similarly, at x is equal to 1, y is equal to 0, it is 2k. X is equal to 1, y is equal to 1, 3k. X is equal to 1, y is equal to 2, 4k. X is equal to 1, y is equal to 3, 5k. Similarly, x is equal to 2, y is equal to 0, it is 4k. X is equal to 2, y is equal to 1, 5k. X is equal to 2, y is equal to 2, 6k. X is equal to 3, y is equal, x is equal to 2, y is equal to 3, it is 7k. So now adding this complete x columns with respect to 0, 1, 2. So we got the values of f of x1 is 6k, f of x2 is 14k, f of x3 is 22k. Similarly, adding all the columns with respect to y. So g of y1 is 6k, g of y2 is 9k, g of y3 is 12k, g of y4 is 15k. So now adding this all g or all f, it will be equal to 42k. So now our job is to find the value of k. So to find the value of k, we must have this last value must be equal to 1. That is 42k must be equal to 1. Then k will be equal to 1 by 2. Okay, now I am going to frame the marginal distribution of this table. So therefore, x is given by actually saying it is 0, 1, 2, y is 0, 1, 2, 4. With respect to this x and y, the values of f of xi is 1 by 7, 1 by 3, 11 by 21, and g of yj will be 1 by 7, 1 by 4, 2 by 7, 5 by 14. So now it can be seen that the value of f of x and g of yj is not equal to jij here. So hence we can say that the random variables x and y are dependent random variables in this case. So now next problem, a pair of coin tossed thrice, the random variable x and y are defined as follows. So x is equal to 0 and 1. So I am taking in this problem, we will be taking x is equal to 0 or 1 according to the head or tail occurs in the first toss. Similarly, y is equal to given by number of heads in the toss. So now from this data, we have to calculate the distribution of x and y and find the joint distribution of x and y. Also obtain the expectation of xy, x comma y and x into y, and also find the standard deviation of x and y for compute covariance and correlation of x and y. So we'll calculate that. So first, make a sample space S of the random variables x and y. So the outcome. So tossing a coin 8 once. So 3 coins once. So the sample space will be like this. That is 3 heads: head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail will be having. So for this, the possible outcomes will be, for the range of x will be 0, 0, because here no tails at all. This is 0, 0, 0, 0, 1, 1, 1, 1. So y will be equal to 3, 2, 2, 1, 2, 1, 1, 0. So therefore the range of x will be equal to 0, 1, and the range of y is 0, 1, 2, 3. So now I am going to calculate the p of x0 value. So p of x0 is nothing but what? The toss one is head. It is given by 4 outcomes out of 8. That is 1 by 2 will be getting. This is p of x is equal to 1. So p of x is equal to 1 means the toss 1 is tail. This is 4 outcomes we are having. 4 outcomes out of 8, that is 4 by 8, it is equal to 1 by 2. So next I am going to calculate p of y is equal to 0. So p of y is equal to 0 means no heads. So no heads means only one outcome you are having, that is 1 by 8. So next is P of y is equal to 1. So P of y is equal to 1 means one head. So one head is 3 outcomes we are having, 3 outcomes out of 8. So next is P of y is equal to 2, 2 heads. So 2 heads means we are having 3 outcomes out of 8, that is 3 by 8. P of y is equal to 3, all 3 heads. So 3 heads means we have only one outcome, that is 1 by 8. So therefore the marginal distribution of x and y is, so first one is y. So y is given like 0, 1, 2, 3. So g of yj will be 1 by 8, 3 by 8, 3 by 8, 1 by 8. So now I am going to calculate the value of joint distribution table. So first one is jij. The formula will be p of x is equal to xi, y is equal to yj. So now I am going to calculate p of x is equal to 0 and y is equal to 0. So p of x is equal to 0 means toss 1 is head, y is equal to 0 means no heads. It is an impossible case. So I will be getting j of 1 1 is 0. Similarly, j of 1 2. So j of 1 2 will be toss 1 is head and 1 head. It is 1 by 8. So j of 1 3 is toss 1 is head and 2 heads. That is 2 by 8 will be equal to 1 by 4. So j 1 4 toss 1 is head and 3 heads. It is 1 by 8, only one outcome you are having, that is h h h. J of j 2 1. So p of x is equal to 1, y is equal to 0. So toss 1 is tail, no head. That is 1 by 8, one outcome, that is tail tail tail. P of x is equal to 1, y is equal to 1. Toss 1 is tail and 1 head. It is two outcomes we are having, 2 by 8. So t h t t t h. P of x is equal to 1, y is equal to 2. So toss 1 is head, 2 heads. 1 by 8 outcome, that is t h h. X is equal to 1, y is equal to 3. So toss 1 is tail, all 3 heads. It is an impossible case, that is 0. So now we got the joint distribution table also. That xy, x is given like 0 1 2, y is given like 0 1 2 3. So 0, 1 by 8, 1 by 4, 1 by 8, 1 by 8, 1 by 4, 1 by 8, 1 by 0, 1 by 8, 3 by 8, 3 by 8, 1 by 5. After adding all the columns, after adding all the rows, we got 1 by 2, 1 by 2. So adding this column and this row, we got the value equal to 1. So now is expectation of x. So same like a previous problems only. We'll be calculating summation xi into f of xi. So replacing all the data over here, we'll be getting expectation of x is 1 by 2. So next is expectation of y. The formula is summation I yj gyj. So therefore the mu y value will be 3 by 2 after calculating. So next is expectation of xy. So the formula is summation xi yj jij. So replace all the values over here. We'll be getting the value of e of xy is 1 by 2. So next is standard deviation. So the formula is expectation of x square minus mu x square, and sigma y square is expectation of y square minus mu y square. So by simplifying the sigma x square, we got the value 1 by 4. Sigma y square is 3 by 4. Therefore sigma x will be equal to 1 by 2 and sigma y will be equal to root 3 by 2. So now the last part, covariance and correlation, I am going to calculate. The formula for covariance is expectation of x comma y minus mu x mu y. So it will be equal to what? Covariance of x comma y is equal to 1 by 2 minus 3 by 4. It will be equal to 1 by 4. So next is correlation of x comma y. Covariance of xy by sigma x sigma y. So we got rho of x comma y is equal to minus 1 by 4 divided by 1 by 2 into root 3 by 2. On simplifying this, we got minus 1 by root 3 is the value of correlation. Therefore we got covariance of xy is minus 1 by 4 and correlation of xy is minus 1 by 3. Thank you.